Hello, my name is Sammy, and today I'll be presenting the progress we've made on our FarmSmart AI prototype. Our goal is to develop a smart farming solution that utilizes IoT sensors and AI to help farmers monitor soil conditions and optimize irrigation. In this demo, I'll walk through our current prototype, focusing on the moisture monitoring system, the front end, and the technologies powering our project. Let's get started. Let's start with the soil moisture monitoring system. For our moisture monitoring system, you can see that we used a capacitive soil moisture sensor because of the resistance to corrosion and increased longevity. And as far as libraries are concerned, we are using Adafruit's CircuitPython library, which has a bunch of submodules which allow us to interact with the sensor and read data from it. And the code I've wrote up for this prototype will read and check for moisture level changes on a constant loop, and then it'll print the moisture level to the console. And if the moisture level changes, it'll notify the user, print it to the console, and then start posting these moisture level results to our MongoDB/CosmosDB cluster. The soil moisture sensor we will be using is an Adafruit Stemma capacitive soil moisture sensor. This is the sensor wired to the Raspberry Pi. So now I'm going to demo the script I wrote to read moisture. So I've just ran a simple Python script that is reading the moisture level. And then once you can see as I touch the sensor, the moisture level increase is detected and printed to the console. And for each of these readings, an entry is made and then subsequently posted to our Mongo cluster, which I'm about to show you right now. Let me refresh our database and make sure that all of these items have posted as they should have. And as you can see, they have. So each of those moisture level readings is posted as a document to our Mongo cluster. Now we will move on to the second part of our presentation, which is data processing and storage. The data processing and storage portion of our project is a work in progress currently. We are now able to read moisture levels and then post them to our Mongo cluster. And now we have data that we can aggregate and then train models on in the future to make predictive irrigation recommendations along with several other analytical deductions. So we are moving in the right direction with that. Moving on to section 3 of our demo, which is the front-end dashboard. It's really just a simple front-end dashboard that I've thrown together to give a sneak peek of what the application side of things will look like. Okay, so right now I'm located in the root directory of our Raspberry Pi, and I have built a simple Flask web application entry point to just display some data, or some dummy data rather. And I'm just going to go on and launch the Flask application and show you guys. So right now, this is kind of just a work in progress application side of things, where right now we're displaying the current temp, the moisture level of the plant, hopefully some kind of growth over time chart, or even moisture level over time chart, and then a summary generated by AI of the current status of the plant and other recommendations. So now we come to our conclusion summary section. So for milestone 12, our goal is to have functional prototype demonstrating core capabilities. Things we've successfully done: we've integrated the capacitive soil moisture sensor with the Raspberry Pi. We are able to set up real-time data collection and storage using MongoDB and Azure. And we have also displayed and developed an early version of our front end. And looking ahead, we plan to refine AI models based on this data, enhance the front-end experience, and also integrate additional sensors. Here is a little sneak peek of what our roadmap looks like from here. And that includes the things I've mentioned on the previous slide. And that's it. Thank you guys for watching, and we'll see you later.